So back a while ago, LA Fitness opened up what then was a new place at the end of Washington. You see it when you're coming off of Washington and Woodward. They had a new location. They had a couple different deals for a couple. They had one of two offers. So either you could spend, what was it? It was $350 to sign up and $45 a month, or you could spend $250 to sign up and then pay $55 a month. They actually had another one too, but looking at two of these is good enough for our purposes here. So we want to decide, well, which one should I sign up for? If I'm looking at something for me and my wife, want to figure out what I want to sign up for, which one's better? Now, I've graphed both of those two here. Can you tell me which one is which? Which line is which? Which line is, say, this one with the more expensive startup fee but the less monthly fee? Which one is which, do you think?
The one that has a higher startup, it that's on average lower than the other one.
All right, so the higher startup, that's going to be right here. So keep in mind, this is basically in slope-intercept form, right? There's your slope, there's your intercept. So your intercept is right here, y equals, and I'm going to write it as 45x plus 350. And then the other one, of course, is y equals 55x plus 250. Now, why do you think I'm concerned about these lines? What do you think I'm interested in knowing? Or which one of these would you pick to sign up with? It's a good question. I mean, ultimately, you're getting the same location, you're getting the same services and stuff like that. So which one's better? Which one would you care about in the long run?
350.
350? And why is that?
Because like you said, in the long run, as time goes on, you're going to have to pay less and less compared to the other one.
Yes.
Lower, but since the monthly, you're just going to keep adding on.
So I guess the best answer, and you're right, you're exactly right with your analysis. The best answer is, well, it depends how long you're going to stay a member, right?
Oh, yeah.
Because if you're only a member for a short while, then you're better off paying, less of a fee and more of a monthly fee. But if you're in it for the long term, like you were saying, if you're in it for the long term, you better be paying the lower monthly fee, and that would be this one. So the question is, well, where's the break-even point? At what point do you say, okay, well, here's the break-even point. After this, I want to be on this one and not this one. And that break-even point is right here. So we can kind of see its coordinates, right? It has coordinates of 10 and 800. So at 10 months, you're spending $800 regardless of which one of these you're in. After that, you definitely want to be in this one as opposed to this one. Now, this is an example of a system of equations. There's an infinite number of pairs of points to satisfy each line, but there's only one of them that satisfies both of them. And that's going to be our solution. That's what we're going to be looking for in this chapter, is where do these lines cross each other? Now, that's going to become a little more challenging when we start looking in 3 dimensions, but for now, it's just 2 dimensions. So let's move down below. Here's another system of equations, and if I'm looking at this right, this one is 0.5x plus 0.5y equals 6, and then the other one is x over 2 minus y over 2 equals 2. All right, so both of those are looking okay. The question is, what's the solution to this system of equations? Can you tell me? Can anyone tell me? Yeah. The solution to your system of equations is just this point where they cross each other. So that point is, as you said, 8 and 4. And you can just read it off. Now, a lot of times, I'll put something like this on an exam. I'll give people the questions, And this one's probably not the easiest one to solve, all right? But you don't really have to solve it. The solution is right there for you. Now, if a system of equations has a solution, it's called consistent. So this is a consistent system of equations. All right, that's cool. Let's move down below to this one here. And what do you think? Is this one a consistent system of equations as well?
No.
Why not?
Parallel lines.
Oh, yeah, these lines don't cross each other, right? So if they don't cross each other, they can't intersect. And if they can't intersect, then there's no solution. So if you're not consistent, what would you be? You're inconsistent. Yeah, so this is an inconsistent system of equations. So yeah, both of these are parallel. Let's see, the lower one has to be the orange one. Right there. And then this is the other one. All right, great. Now, sometimes you're not going to have a graph to work with. Sometimes you're going to have to do some of this stuff yourself. But, let's see. If you had to do this yourself, then one of the things you'd be stuck with is plotting points. So, I've already plotted a couple points here for you. Let's see if we can't plot some more points and graph this equation. I've already graphed this one for you. So, let's do that in yellow. And that one's here. Now, how are you going to graph and find points for that line? What are you going to do? My suggestion would be to do this. Try and find a couple easy points to work with. And the easy points would be by setting x equal to 0 and setting y equal to 0. Now, the benefits of setting x equal to 0 and y equal to 0 is when you set x equal to 0, you're going to get the y-intercept. When you set y equals 0, you're going to get the x-intercept. And if you play around with these for a moment, I think you might find something interesting about the graph of this line. So take a moment, see if you can't plot those points. Plug in x equals 0, solve for y. Plug in y equals 0, solve for x. Gavin, if I set x equal to 0 in this equation, what do I get for y? Yeah, 5 times 0 plus 2y equals 6 was really 2y equals 6, so y equals 3. Good, so 0, 3, nice. Did anyone get this other solution? When you set y equals 0, what do you get for x? 1.2. Yeah, you get 1.2. You get 6 over 5, which is exactly 1.2. So great. So what's that telling me about my line then? What's happening with my line? Yeah, it's the same line. So wow, there's really an infinite number of solutions here because the two lines are the same. They intersected in an infinite number of places. Now when that happens, we have some vocabulary to describe this. This is called a dependent system of equations. Okay, great. Now what makes it a dependent system of equations is if the equations represent the same line. So that's a nice interpretation for this section. If you're not dependent, then what are you? Independent. Independent. Nice. How about this one up here? The first one we looked at. well, I guess the second one we looked at, but is this dependent or independent?
Independent.
Are they the same line?
Oh, no, independent.
Independent. Great. Now there's one left that I didn't do on this, and that's this one. Now both of these are graphed. Can anyone tell me which one do you think looks like the line y equals x? Which one would that be? Be this one here in the fourth and second quadrants, or this one here in the first and third quadrants? First and third. The line y equals x is just going to have points like 1 and 1, 2 and 2, 3 and 3, etc. And so here. But sometimes I cheekily refer to this one as solving by graphing without graphing. And why would I do that? Well, it's a good question. Both of these are in slope-intercept form. Let's remember slope-intercept form. Y equals mx plus b. So in this case, I get y equals x. What's b in this case? What's the y-intercept? 0. And for the second one, well, that's also in slope-intercept form. So we get y equals negative 3/2 x. Someone else for this one. Charlie, what's the y-intercept on this one? 0 again. So without really even graphing these things, they both have the same y-intercept. That has to be your solution. That's where those two lines cross. So it's nice that we can see it visually, kind of positive reinforcement there, but 0, 0 is a solution. Is this going to be dependent or independent? Independent. Consistent or inconsistent? Consistent. Consistent means there's at least one solution. So how about down here? What do you think of that one? Our dependent system equations. Is that consistent or inconsistent? Is there at least one solution there? Yeah, this is an infinite number. So this is, again, consistent. The only time you're going to get something that's inconsistent if the two lines don't cross. In other words, they're parallel lines. Nice. Now, kind of a review question for you in a minute. But before I go to the review question, are we okay with what we're looking at here? There's basically 3 different things that can happen when you're trying to find the solution to a 2x2 system of equations. That's 2 equations and 2 unknowns. The nice thing that can happen is you can get a consistent independent system of equations. You could also get something which is inconsistent. Or you could get something which is dependent. Those are the generic 3 things that can happen when you're trying to solve a system of equations. Now, a lot of times we won't actually be looking at the graphs, but it's a good idea to keep in mind what's going on with the graphs as you work your way through these problems. Are we okay with what we've got so far? It wasn't me.
Attention. May I have your attention? An emergency has been reported in the building. All occupants, please walk to the nearest exit and evacuate the building.
Okay.
I repeat, please walk to the nearest exit and evacuate the building.